Omnibus salvete amici, ego sum Joshua, et odie apud astronomia loquemur etiam et perspicacionem. Volo, vobis, benvenutis, erit apud hic lectionis. Good afternoon, brave new world. Joshua again here with a brand new video in which we are going to have a brand new section of this particular part of my channel that I enjoy calling Astronomy section. Astronomy section with Mr. Asimov and this particular person right here, Joshua here. Hello guys, wait a minute. How do they look better? Like this? I'm not sure. Now, the following episode is going to be one that I've been looking forward to making. Why? Why do I say that? I say that because it's one that I've been looking forward to making. It is one that I've been looking forward to making, and one that is particularly dedicated to three special people. Andrew and your brother Carlos, Andrew and your brother Charles. If you guys are watching this, the following episode of this particular section called Astronomy Support with Dr. Asimov, this section is totally dedicated to you guys. This section is totally dedicated to you guys. Additionally, you asked me directly for a question. You asked me directly for a specific number from Mr. Asimov. So I'm going to read you. I'm going to dedicate the following lesson to you guys. Today's lesson is gonna be about the question number 30. The question number 30. I think that's the number that you chose. Unfortunately, I lost the notes where you had written these things, alright? So in advance, I would like to apologize if this is not in reality the lesson that you guys were hoping for. Now, let us not forget that the following thing that I'm about to share with you guys are pure facts. The following information that I'm about to share with you consists entirely of mere and pure facts. Therefore, it means that you can actually double check and fact check everything that I'm saying with a simple Google search. So, the question number 30 goes like this. How was the Earth formed? Question number 30, page number 70. How was the Earth formed? I believe that this one is a particularly easy question, but at the same time a difficult one, because no one actually knows what was before the Big Bang. No one really knows what was there before the Big Bang, which was the major explosion that caused a big cloud of dust, which got condensed and suffered a series of chemical reactions which caused the universe and our galaxy, and then the stars and their solar systems, and then eventually this particular Earth. Basically, it's a conglomeration of chemical reactions. Correct me if I'm wrong, but that's what I was taught back in the day when I was a wee little lad. That's what I was taught. Let's have a look at what the words of Dr. Asimov are. And one more time, the following words also are a little slap in the face of flat earthers. Guys, again, these are facts. So if you come at me with the intention of trashing me or even insulting me, don't waste your time. It goes like this. Oh, but before we have a look at this particular question, we need to have a look at some previous background, such as the view of Copernicus, which is supposed to be the model that proposes that the Sun is the center of the solar system, not the Earth. And also, it proposes that the Earth is not the center of the universe, and neither is our galaxy. Our galaxy is just one tiny grain of salt in this magnificent beach called the Milky Way, like the chocolate brand. So back to the question that says, how was the Earth formed? Question number 30. Now that we have a clear picture of what the solar system is like, we can ask ourselves how the Earth was formed. How the Earth was formed. we can't really consider how the Earth was formed all by itself, for, as we shall see, it had to be formed as a part of a larger formation, that of the solar system as a whole. So, what happened 4.6 billion years ago that brought the Earth and the whole solar system in general into existence? One thing is for sure that we don't know. One thing is for sure we don't know, and one thing is for sure, and that is that Galactus, Galactus, the devourer of worlds, lived here and existed before the Big Bang. If there is any nerd, a real nerd and a real geek person who is interested and really into this kind of comic books, fact check me on that one, please. Fact check me on that one. Please. Let us continue in this part that says, one person who took up this question without referring to the old biblical story, for which of course there is no scientific evidence, even if there are several Jewish scientists who were precisely that Jewish, despite the fact that many people believe that science and religion cannot go hand in hand. Let's not forget that. Alright, one more time. One person who took up this question without referring to the old biblical story, for which of course there is no scientific evidence, was the French naturalist Georges Louis de Buffon, born in 1707 and died in 1788. And it goes like this. Let's see. Oh, hold it. It says that in 1749, Buffon had thought that the Earth might be 75,000 years old. In 1749, Buffon reasoned that the planets, including the Earth, were related to the giant sun rather like chicks to a mother hen. Perhaps then he suggested that the Earth was born of the sun, metaphorically speaking, because you cannot ignore that one person that is going to come out and say, hey, but the sun is not a woman. It is a metaphor, you dingus. It is a metaphor, you dingus. Continues saying. Mr. Asimov continues saying, Buffon visualized the collision of the sun with some other large body and imagined that the impact had somehow jarred a piece of the sun loose, which cooled down and became the Earth. This suggestion was interesting, but it didn't account for the other planets, nor did it account for the formation of the sun. It assumed that the sun was just simply there. Now that's a possibility. But hey, to be honest, if you take into consideration the time that this hypothesis was was created, that was actually a quite groundbreaking way of thinking, For the years 1700s, that's actually a groundbreaking way of thinking about things. A better explanation was needed. Therefore, after Kepler had produced his picture of the solar system, it was clear that it somehow represented a unit. All the planets move in almost the same plane, so that the entire model of the solar system could be fitted into a gigantic pizza box. I like pizza. And they all revolve around the sun in the same direction as did the moon above the Earth and the satellites of Jupiter around Jupiter. Let us not forget that Jupiter is the big gas giant that has the most moons, and additionally it acts like a gravitational shield, because if any object that is floating around space as a rogue celestial body, Any object that is floating around like a rogue celestial body is attracted by the enormous gravity of Jupiter, which attracts any object that could easily crash into the Earth. For that thing, we thank you, Jupiter. Thank you for doing that thankless job. In that way, you are kind of the Hades of the planets. You are the Hades in this Olympus called the solar system. Let us continue. In addition, they all rotated on their axis in the same direction, as did the Sun. Astronomers assumed that the solar system wouldn't show these similarities if it hadn't been formed all in one piece, so to speak. But what if multiple pieces appeared over time? I'm formulating that hypothesis, alright? As you can see, I want this to be a fair use video, therefore I'm reading the book and at the same time I'm making comments about it. Please YouTube, do not copyright strike me. Let us continue. The first suggestion that dealt with the formation of the solar system rather than merely with the Earth came as a result of the realization that there was more to the starry sky than merely stars. Hey! Van Gogh saw more than just a starry sky. He saw a conglomeration of colors. He saw a commonwealth of spectrous possibilities, and also he saw one beautiful source of inspiration. After I record this video, I'm going to check the Van Gogh painting. In 1611, in the very early days of the telescope, the German astronomer Simon, I'm going to pronounce it Simon because it's a German person, therefore it would be a little bit weird and off the wall to pronounce it. Simon Marius, born in 1573 and died in 1624, detected a luminous hazy patch in the constellation Andromeda. It was called the Andromeda Nebula. A nebula or nebula if you want, is the Latin word for cloud. Oh, so that's why you call them nebulas. These conglomerations of gases that are kind of the gestation belly of the universe wallpaper that is going to eventually give birth to galaxies, quarks, new planets and stuff, because I assume that's why you call it a cloud. Then in 1694, Huygens, who's that? Huygens, the inventor of the pendulum clock, detected a luminous hazy patch in the constellation of Orion, I'm not sure how you pronounce it in English, the Orion Nebula. Fun fact, if you check more videos in my YouTube channel, you will see that one of my cats is named after that constellation precisely, Orion. That's a beautiful name, to be honest. I think that's actually a beautiful name, Orion. How do you pronounce it, English-speaking folks? Please write it down in the comments. Please write it down in the comment section below. Let us continue. Other nebulas were also located. The proper Latin plural of nebula is nebulae. Nebulae. I'm going to pronounce that nebulae. Given that I am a Spanish speaker, I find it easy to pronounce that one. However, I'm pretty sure that English-speaking folks are going to have probably a tougher time with the pronunciation of Latin words. That was just a description and friendly banter, right? I'm not trashing you, English-speaking people, because hey, I'm using the English language in order to produce this video, so please, don't be offended. I will only trash flat earthers. Those guys are a big waste of life, flesh, blood, and air. Let us continue. Oh, I like the sudden changing illumination. Wait, what happened to my source of light? Nah, nothing happened. Let us continue. Other nebulas were also located. The proper Latin plural of nebula is nebulae, but in recent years the English system of adding an S for a plural has been adopted, so everyone would say nebulas. Nebulas. It seemed possible that such luminous clouds were vast conglomerations of dust and gas that had not yet condensed to stars, and that all stars might have been nebulas to begin with. Continue with the next idea. In the year 1755, the German philosopher Immanuel Kant, I have seen plenty of memes about him, and I have seen that he knew a lot about the world based on the memes I saw, but he never left his town. That's the part that I remember the best. So one more time. In that year, 1755, the German philosopher Immanuel Kant, born in 1724 and died in 1804, published a book that suggested just precisely this, right? He thought that a nebula was slowly brought together by its own force of gravitation, swirling as it did so. By mentioning the word swirling, I kind of think about a washing machine. What do? They swirl. They create a water tornado. Let's call it that way. The central portion became a star, and the outer portions became the planets. This proposal seemed to explain why all the planets should move in the same plane and move and rotate in the same direction. In 1798, the French philosopher Pierre-Simon de Laplace, born in 1749 and died in 1827, who possibly did not know of Kant's earlier work, described the same idea in a book he wrote. But went into greater detail, He pictured the nebula as slowly contracting, and as it contracted, the whirling of the nebula grew faster. This is not an idea that Laplace had to invent. The contraction is the result of gravitational pull, which we know works because it works within the solar system, and the accelerated whirling of the nebula as it contracts follows the law of conservation of angular momentum, an effect every ice skater knows. This is an effect that every ice skater knows. Who goes into a spin and then spins faster when he draws his arms closer to his body. Yeah, I think I'm familiar with this one. Basically, spread your arms. You don't see it right now, but I'm spreading my arms. Spread your arms and you turn around slowly. But if you put your arms close to your body, you're going to swirl faster like a tornado, like a faster tornado. So let us continue. As the nebula contracted and whirled faster and faster, its central regions bellied outward and came loose. This process too does not have to be made up. It is the result of the centrifugal effect, which is well known from observations and experiments on Earth. Laplace, the French, what was he? He was a philosopher or I don't remember. Was he a philosopher or a physicist? I think I got lost. Anyway, let's continue. Laplace imagined that the proportion that came loose contracted and formed a planet. The central regions continued to contract, and another planet was formed. Then another, and soon all were spinning in the same direction. Finally, what was left of the central region became the Sun. Because Kant and Laplace started with a contracting nebula, the conception of the formation of a solar system is called nebular hypothesis. A hypothesis is a suggestion that doesn't have the strength of evidence behind it that a theory has. What Dr. Asimov is doing in this particular paragraph is proposing former models and theories about the formation of the Earth, or in this case, about the formation of the Earth, that were proven or disproven sometime later. It is important to provide some background and some context to an idea before answering that question. Answering the question and proposing or giving an idea. For a century, astronomers were more or less satisfied with the nebular hypothesis, but unfortunately, they became steadily less satisfied. The trouble came from the manner of angular momentum. Angular momentum measures the quantity of spin of an object, which is partially due to the object's rotation about its axis and partially due to its revolution about another object. The planet Jupiter, rotating about its axis and revolving around about the Sun, has 30 times the angular momentum of the Sun, which is a much larger body. All the planets put together have nearly 50 times the angular momentum of the Sun. If the solar system began as a single cloud with a given amount of angular momentum, how did almost all of that momentum came to be concentrated into little bits of matter that broke off from the planets? Astronomers couldn't reach an answer, and they began search for other explanations. What it's proposing is kind of like a mitosis, I think. Imagine a kind of bacteria that divides. Normally the mitosis, it's supposed to be a process in which a cell, vegetable or animal, multiplies by 2. 1 becomes 2, and those 2 become 4, and those 4 become 16, and those 16 become 32, and it continues like that until the infinite, until the 8 put horizontally. However, this one, it's more like, it proposes that basically 2 pieces of bread crash, and naturally it causes some tiny bits of bread to be around, and those pieces of bread start to develop life. Correct me if I'm wrong. Please let me check if I understood it correctly. Continue with this one. In the year 1900, 2 American scientists, Thomas Chamberlain and Forrest Ray Moulton, one was born in 1843 and died in 1928, and the other was born in 1872 and died in 1952. These 2 guys returned to a version of the Buffon's idea, the French guy from a few paragraphs ago. They suggested that another star passed near the Sun long ago, and then that the gravitational pull between them drew matter out of each. As the star separated, the gravitational pull of this matter caused a spinning motion and set it whirling, so that the planets were given a great deal of angular momentum. After the final separation, the matter condensing to small solid or planetesimals, and these further collided and combined into planets. The 2 stars, having come together singly, each departed with a family of planets. This explanation was called the planetesimal hypothesis. Hard to understand, isn't it? I bet it is. We have time. Yes, we have time. One difference between the 2 theories is particularly important. If the nebular hypothesis is correct, then every star might form with planets. If the planetesimal hypothesis is correct, only stars that had experienced a near collision would have planets. And stars, the first one, it's about just dividing on its own like a bacteria, and the other, it's the traces that are left after a collision. Correct me if I'm wrong. If the planetesimal hypothesis is correct, only stars that have experienced a near collision would have planets, and stars are so far apart and move so slowly compared to distances between them, a near collision must be very, very rare. Therefore, I think the previous one is the correct one. The difference then is between very, very, very many planet systems for the nebular hypothesis and very, very few for the planetesimal hypothesis. Oh, so both are correct. Let's find out. As it happens, the planetesimal hypothesis didn't survive either. In the 1920s, the British astronomer Arthur Stanley Eddington, born in 1882 and died in 1944 during the World War, showed that the interior of the Sun was much hotter than anyone had expected. There will be more to say about this later. Material pulled out of the sun or out of the other star would be so hot that it could not condense into planets, but would spread out into space. The American astronomer Lyman Spitzer, born in 1914, it means 1914, showed this convincingly in 1939. In 1944, the German astronomer Carl Friedrich von Weizsäcker, born in 1912, returned to the nebular hypothesis but improved it. He pictured the whirling, the tornado movement, the whirling nebula as developing subworlds that form first planets and then planets. Astronomers could take electromagnetic fields in the nebula, something not known in Laplace time, into consideration to account for the way in which an angular momentum was transferred from the Sun to the planets. The formation of planets from planetesimals, by the way, explains the internal heat of the Earth. The planetesimals are moving quickly and have enormous kinetic energy, but as they smash together, they come to a halt They come to a halt and yes, I'm almost done. It comes to a halt and the kinetic energy turns to heat. Let us not forget the law of conservation of matter. I think matter is neither created nor destroyed. It is only transformed. It only transforms into other things. By the time a planet is formed, the heat produced by all the by the time a planet is formed, the heat produced by all the halting of motion is enormous, which is why the Earth's core might be as hot as 5,000 degrees Celsius. Naturally, the larger the planet, the more kinetic energy has been turned into heat in the process of its foundation, and the hotter it must be at its core. The smaller a planet, though, the less kinetic energy was involved in its planetesimals to begin with, and the cooler it must be at the center. Thus, the Moon is undoubtedly much cooler than 5,000 degrees at its center. Since it's smaller than the Earth and Jupiter, which is larger than the Earth and indeed the largest planet, must be considerably hotter. I totally agree. Some scientists place the eternal temperature of Jupiter at 50,000 degrees Celsius. And I say Celsius, not Fahrenheit. It would be 90 degrees Fahrenheit. For now, then, the new version of the nebular hypothesis seemed to be quite satisfactory. That's what caused the Earth to be formed. And that is not the story, but the facts that tell you the situation that caused the Earth to be formed. One more time, Irving, Charles, or Andrew, if you're watching this is for you. This is for you, guys. I have to say that it was quite informative and quite educational and really enlightening. However, in this moment I'm hungry and I would like to go to have dinner right now. I'll see you later in this new episode of Astronomy Support with Dr. Issac Asimov. I am not Issac Asimov, but I have a book from him.